All right, let's do some more practice here. We have, for example 2, 9x squared plus 2x minus 1 over x minus 1 times a 2x squared plus 7x minus 4 dx. All right? Okay. Now, well, my denominator is bigger, right? Because this is a cube, because I've got squared and x. So I can't just divide that or work with that. So let's factor this down. So obviously x minus 1 is already a factor. I've got 2x and x with the minus in the back. I know my signs are going to be different. I can't do, so here's back to factoring, looking at factoring pieces, right? I know there's no greatest common factor here. So if I think of 4, there is no way for me to do a 2 and a 2 because then I would have a common factor of 2 there. And if you don't have a common factor in your original, then you can't in your parentheses. So it makes it easy. This has to be a 1 and has to be a 4. Then I look at this and check my outsides. That's going to be a positive 8 and a negative 1 gives me that 7. All right, so however you factor, I just do FOIL factoring, and then we can work that out. If you ever have any questions about factoring, make sure you're asking, because I know that's usually a thing. All right, now let's do this. Partial fractions, here we come. 9x squared plus 2x minus 1 over x minus 1, 2x minus 1, and x plus 4. So I have a over x minus 1, b over 2x minus 1, and c over x plus 4. All right, common denominator. Represent the whole thing. X minus 1, 2x minus 1, and x plus 4. So I end up with a 9x squared plus 2x minus 1. This is a times my other two factors, b times my other two factors, and c times, you guessed it, the other two factors. All right. Now, multiply that out, and let's see what we've got. So, 9x squared plus 2x minus 1. If I FOIL this, we've got 2x squared. Oh, we already know what that one is. But plus 8 minus 1 is a 7 minus 4. If I FOIL this one out, you get x squared plus 4 minus 1 is a 3x minus 4. And I've got 2x squared minus x minus 2x plus 1. Right? Now distribute that through. I'm going to scoot this up. Distribute that through and combine our like terms. 9x squared plus 2x minus 1 is 2ax squared. 7ax minus 4a. A bx squared plus 3bx minus 4b. 2cx squared minus 3cx plus c. Woohoo! We've got a lot going down here, don't we? They all have an x. The x squared, the x, and the numbers all have 3 variables that we get to work with. So, I've got 9x squared plus 2x minus 1 is equal to 2a plus b plus 2c is my x squared coefficient. 7a plus 3b minus 3c is my x coefficient. And then my constant is negative 4a minus 4b plus c. So when we set up this system of equation, I have 2a plus b plus 2c is equal to 9. Do you see that? 9 goes there. Then I have 7a plus 3b minus 3c is equal to 2. then we have negative 4a minus 4b plus c is equal to a negative 1. Right? I got a mark on there somehow. All right. When you have a 3-variable system of equation, all right, so I like doing this one just because it's a good review for how to solve a 3-variable system of equation. You look to eliminate a variable. Put 2 together and move on. Now, something else I will tell you right now. When you get to these problems, here is why I showed you the shortcut. When you get to these problems and you get down to this point and you're like, oh my goodness, do I really want to do a 3-variable system of equation? These are simple linear factors. You can do the shortcut here. So I'm going to let you know that. So if you want to pause this video, go try the shortcut method and come back, you are welcome to do that. Because if you try the shortcut method, x would equal 1, x would equal 1/2, and x would equal negative 4. Right? For this video, because you can't always do that, I want to review the 3-variable systems of equations, so I'm going to work this out that way. If you want to try the shortcut method we learned last time, we're going to end up in the same place. But I want to go through a 3-variable system of equation just so to refresh you on how to do that. All right, so I'm going to do it this way for that purpose, but no, you can go back and do the other one. Okay, so here we go. When you have a 3-variable systems of equations, you have to eliminate one of the variables, right? So you have to decide, am I going to go for the A, the B, or the C? It doesn't matter. It doesn't matter at all. All right? We are going to have to put 2 equations together in order to get that. Now, I've got a ton of coefficients here on A, so that would be a bad choice. We could go with B, because you have this single B makes it easier. Or here with C, you have a single C makes it easier. Normally I ask you guys what you want to do. I'm going to go with C, just because why not? There's smaller numbers, so I'm going to put these 2 together to make one equation. And I'm going to put these 2 together to make the second equation. All right? Okay, well, let's stick with our colors. So new number 1, I'm going to put those bottom 2 together. So 7a plus 3b, wow, not even sure what I'm writing. 3b minus 3c is equal to 2. Negative 4a minus 4b plus c is equal to a negative 1. Now, if I'm going to eliminate the c, remember, elimination method, I'm going to multiply through by a 3. Because I want to have a positive and a negative as my coefficients. I already have the negative 3, so I just multiply through with a positive 3. This gives me 7a plus 3b minus 3c is equal to 2. Negative 12a minus 12b plus 3c is equal to a negative 3. Those cancel, and I add these up. 7 minus 12 is a negative 5a. 3 minus 12 is a negative 9b, is equal to that negative 1. This is my first new equation with only 2 variables. Now I got to come up with a second new equation with only 2 variables, because then I can use those for my system. All right, so here I'm going to write 2a plus b plus 2c is equal to 9. Negative 4a minus 4b plus c is equal to a negative 1. Now my goal is, you have to get rid of the same variable. So my c is what I'm getting rid of here. So because of that, I have to multiply this bottom by a negative 2, because remember we said the positive and the negative. Okay, so it's already positive c. So in order to get the negative 2 to go with it, I have to multiply by a negative 2. Okay. So 2a plus b plus 2c is equal to a 9. Negative times a negative is a positive. 8a plus 8b minus 2c is equal to a positive 2. Now, I will tell you, especially with these three variable systems, watch all of your negative signs. It's so easy to make an error with that kind of stuff, and then it throws off your whole problem, right? So make sure that you're watching those signs. Oh my goodness, ladies and gentlemen, we just had our best day ever. When I go to put these two together, negative 5a minus 9b minus 1 and 10a plus 9b equals 11. Ah, right? Oh, I'm so excited. Do you see why? The b's cancel automatically. I don't have to do any extra work there. So 5a is equal to 10. Oops, that's an equal sign for my negative. 5a is equal to 10, so a is equal to 2. Once you know what a is, plug it back in. So negative 5 times 2 minus 9b is equal to a negative 1. So I'm going to add 10 to both sides, right? Negative 9b is equal to 9, so b is equal to a negative 1. I know two. As soon as you know two of them, plug it back into an original. I don't know, we could do the top, the middle, or the bottom. Do you guys have a preference? Yeah, just go with the top. Why not, right? Okay, so 2 times 2 minus 1, because it's plus b, plus 2c is equal to 9. So 4 minus 1 is 3, plus 2c is equal to 9. So 2c is equal to 6, and c is equal to 3. Ta-da-ta-da! I'm going to squeeze this back down. I now know my a, my b, and my c, and we can integrate. So my a is 2 over x minus 1. And b is a negative 1, so I'm going to write minus 1 over 2x minus 1. C is a positive 3, so 3 over x plus 4 dx. I'm just taking my a, my b, and my c and plugging them in, right? So now I have a nice, easy integration, and we can make this happen. So 2 natural logs here of x minus 1. Those are absolute values. Minus. Now look at this one. With this 2 on the inside, right? Don't forget, anytime you have that 2 here, like here, there's nothing to go, but I have to do that 1/2 in front just because of that 2x minus 1. If you were to do a u sub, then you would see how that plays out, right? And then 3 natural logs here of x plus 4. And I'm 100% okay with this answer. Or you can put all of those together and you end up with, now keep in mind, we can move these around a little bit. This is plus, so it goes over here with this one. The only thing that's a minus is this piece, so that's the only one that goes in the denominator. I was thinking about rewriting it, but I think you guys can see that. So I have the natural log here of x minus 2 squared, x plus 4 cubed over, and remember this 1/2 is the same thing as the square root of 2x minus 1. And I told you I'm fine with the first one. If you want to do logarithmic properties, awesome, but you don't have to. All right? Cool. If you go back through and do the shortcut method for this one, you'll see you come up with these exact same numerators, those coefficients. All right?